Okay, the difference of two squares is exactly what it sounds like. Difference means subtract, and you would have two things that are being squared that are being subtracted. I would like for you to write this down, and let's take a look at what you see. What's different about them. Okay, in this part right here, you notice we have the exact same thing with our variables a and b, except one has addition and one has subtraction. What happens when you have that, if you think about it, if you were FOILing this, you would get a squared, and then you would get, for your outer and your inner, a negative ab plus ab, which would disappear. Negative ab plus ab would disappear, and so you have no middle term. And then your last part would be your b times b, which is b squared, and it would be minus b squared. So this is called the difference of two squares because this is what it ends up being. You have two squares that are being subtracted. There is no middle term. There's not a trinomial with this. The middle term disappears. Let's take a look at some. Alright, suppose you have x plus 3, x minus 3. Okay, right away, hopefully you say, oh, we've got the same thing except they're different signs in the middle. That means you have the difference of two squares. That means I can take my first terms and I can take my last terms, and it will be minus x squared minus 9. Even if you look at it and you forget that, if you ended up doing FOIL on it or you ended up distributing on it, once again your middle term would disappear and you would end up in the end with x squared minus 9. You'd get the same answer. But you see the plus 3x minus 3x for your inner and your outer would disappear. Okay, let's look at another one. Suppose you had 2a plus 5 and 2a minus 5. Okay, it's the same thing. So I know it's going to be the difference of two squares. I know the middle term is going to disappear because if you look, you'd have 10a minus 10a. It's going to go away. So all I'm concerned about is my first terms being multiplied. So I'd get 4a squared. And my last terms being multiplied. And I would get 25 minus. Let's do one more like this. Let's do xy plus z squared and xy minus z squared. Still the same thing. We have more variables, but they're still the same, except we have addition in one, subtraction in the other. So the first terms, xy times xy, would give you x squared, y squared. And then your last terms, z squared times z squared, would give you z to the 4th, and it will be minus. Okay, let's turn it around, and suppose, be sure you're putting this in your notes, pausing it when you need to, and move on when you're ready. Suppose we go the other way. Suppose this time you are given the difference of two squares, like y squared minus 49. There's no middle term. Y squared is a perfect square. 49 is a perfect square. So I have the difference of two squares. So if I ask you to factor these into the binomials, giving me this part, I know that y times y would give me y squared. And I know that 7 times 7 would give me 49. Also, if my middle term is gone, then I know one needs to be addition and one needs to be subtraction. If you came back and reworked this, you would see you would get y squared minus 49. Okay, let's look at another one. 16 minus 9x squared. Okay, 16 is a perfect square, 9 is a perfect square, and x squared is a perfect square. So we know that it's the difference of two squares. So we should have the same thing in both parentheses, except one will be a plus, one will be a minus. 4 times 4 would be 16, and 3x times 3x would give you 9x squared, make one plus, and the other minus. Alright, what if we had 81a squared minus 25x to the 6th? Okay, 81 is perfect square, a squared is, 25 is, x to the 6th is, because x to the 3rd times x to the 3rd gives you x to the 6th. So, let's break this down. We would have 9a and 9a, and 5x to the 3rd and 5x to the 3rd, 1 plus, 1 minus. And double check yourself, and it should bring you back to 81a squared minus 25x to the 6th. Okay, let's look at one more. Look at 16r to the 4th minus 625. Okay, I know 16 is perfect square. I also know 625 is a perfect square. 25 times 25 will give you 625. So, let's do it like we did the others. 4r squared and 4r squared. And like I said, 25 and 25 plus minus, so the middle term will completely disappear. But in this case, I'm not done, because if you look here, I've got the difference of two squares again. So that means you need to take this one further and break this down into 2r times 2r to give you 4r squared, and 5 times 5 to give you 25. Make 1 plus, make 1 minus, and that would give you the 4r squared minus 25 back if you multiplied it. And then do not forget to bring this back to the front of it. So this would be the final answer of all of it. Okay, that's it. Pause it, get it all in your notes, and then we will practice.